Fine. So we're already looking at multi-threading, right? So fine. The first thing we have looked at was the steps for creating a new thread of execution. And we understand those 4 steps. Okay. Fine. We have the first step for yes, we should have our own class to implement runnable interface. Fine. And then first step would be to create object of the runnable. Fine. Second step, create object of thread using the runnable. And third step, which we say is optional, is about setting up the properties in the thread object. And then calling the start method would create a new thread of execution. Clear? Calling start method on a thread object would create a new thread of execution. Plus, you should always remember that on a particular thread object, start method can be called only once. Fine. Once you're on a particular thread object, we have called a start method. It would have created one thread of execution. After that, you can't call start on that thread object. Fine. It would throw exception otherwise. Okay, illegal state. Fine. So let's continue looking at the thread class, right? The various methods which we have, what are the various properties? Fine. Step 3, setting up properties. Some of the properties we have seen already. Let's list the properties. Yeah. So thread, some are read-only properties. Okay. So for the thread class, okay, the various get set methods. Which are the get set methods? Yeah. Fine, we can list them. Every thread has a name. Fine. So public, all are public methods. So method to return string. Name of the method was get name. Fine. And exactly we had the opposite was set name to take string as a parameter. Fine. The new name which you would like to give. Okay. You can change the name many times. Same way we have the other property was priority to return an int type. Fine. Priority type is int. Set priority parameter is int, the new value for the priority. Yeah. What else? Which one? ID. It's a read only, and the return type is long. Okay. Get ID. Every thread has a unique ID value. Thread object. Fine. Then is alive. We can check if it is alive. That's a Boolean value. Fine. Is alive would be true after start, but before it finishes. Okay. It's false before calling start method. And once it has finished the execution, fine, on the thread object, corresponding thread object, is alive would again become false. Okay. Is alive. Which one? Is daemon. Yeah. Method return Boolean is daemon. D-A-E-M-O-N. Daemon. Okay. Fine. Returns void. We have the method called set daemon. Fine. We understand the meaning of daemon, right? Daemon means mainly these are service threads. Fine. The JVM does not wait for these threads to finish. And they can be written as a while true loop. Infinite loops can be there. And they're continuously just giving service. Okay, making some kind of a service available. Garbage collection related threads, those are the daemon threads. Okay, then a few other, let's list methods, fine, not only properties, other methods which we know of. Some static method we know of. Fine. This is what was discussed. Any other methods that we have seen earlier? Get group, get thread group, returns a thread group. It's a get read only, right? Yeah, we will be looking at this thread group today. Let's try to look at that. Method name is get. It's get only. Okay, get thread group. We don't have a set thread group. Okay. Anything else which we mentioned last time? Okay, let's look at more methods now. We had one static method last time. So let me put the static method here. So there was the static method, yeah, recollect, to return thread object. Method was current thread. Fine. We can know what is the current thread object, and getting to the current thread object returns the thread. Find current thread object. Okay, thread corresponding to your current execution stack. Okay, now, yes, we have a thread object corresponding to every runtime stack, whatever is currently executing. Fine. We have another useful static method. So let me put the static method here. Okay, below here. So there's another static method which returns a map of thread. So key is the thread object, and corresponding to each thread object, maybe I think I should give the non-static method first. I'll write the non-static method first, then I'll come to this method, but before that, one more method. Fine. Recollect, we have that method for we had this method in throwable class. Same method available even in thread object. Okay, so we have this method to return stack trace element array. Method is get stack trace. So if the thread is alive, it has a corresponding runtime stack, getting the stack trace element array. Get stack trace method, fine. Similar to the same as the get stack trace method available in throwable, fine. Fine, whenever an error occurred, fine. If you create a throwable object, it takes a picture of the runtime stack. So the picture of the runtime stack corresponding to a particular thread object, fine. What is currently there in the runtime stack of the thread object? So get stack trace. So for any thread, we can ask for what is your corresponding stack. Fine, picture of the stack. Fine. Get stack trace. Now, the other static method which we have, fine. The static method returns a map of thread with stack trace element array. Fine, a mapping of thread with stack trace element array. Key is thread, the thread object, and its corresponding stack trace element. Fine, this is for your current, fine, on whichever object you ask, you can ask for the stack trace element array. Give me your runtime stack. This is, the method name is get all stack traces. Okay, I can shift it. Yeah. Get all stack traces. And that's a method we have. So get all stack traces returns is a static method which would return a map of thread with the corresponding stack trace. So for every thread, its corresponding stack trace in a single method, you can get all the thread with their corresponding stack trace. Get all stack traces. Fine. So for all threads, this is available. All threads in the JVM. Okay. Fine. So if you want to get hold of all the thread objects, fine. If you want to know what are all the thread objects which are alive, right? There may be more thread objects, but these are all the live ones, which have got running stack with them. Okay, where there is a stack. So all live thread objects. Okay, for all the live thread objects, you get a map like this. So if you are interested in getting, oh, let me have all the live thread objects, then what you can do is, you can do a simple thing. You can say, oh, let me have a set of, I'm just giving the code from that method, fine. How that method could be used. So you can say, oh, I want a set of all the thread object, okay, all threads equal to thread dot get all stack traces dot, what's a method? Key set. And key set is the method of map to return a set of all the keys. Keys are the thread objects. So that's how you can get hold of all the thread objects. All live threads in your JVM. And that's a code for that. As a set, you can get a set of all the thread objects. Right? So initially, maybe as soon in the main method, if you do this, you can know that as soon as you start your JVM, one of the thread would be the main thread, plus there are other threads, as I mentioned, which are the daemon threads, fine, which are getting created. So all that can be examined like this, and you can get hold of them, and you can check them. Oh, what's the whole thing? Okay, fine. Yeah. Another interesting thing, another property, another property of the thread object. On a thread, again, there is also a corresponding static method pair, get and set methods now. And this is get and set both. Fine. So for a thread object, yeah, we understand how the execution happens. How the execution is happening on a runtime stack. Okay, let me show it in short. Here is your runtime stack, right? There is some task given to this, right? From this method, it's invoking a method, it's invoking that method. Fine. Now suppose how does a thread terminate? That's the question. How does a thread terminate? When the method here would finish. How would this method finish? How do you come out of that method? How does your main method or any other method finish? Two possibilities. How? By a return, it has successfully completed, or an exception is thrown. Fine. If it has completed its job successfully, there's nothing to do. But if something happened and your execution has failed, a particular thread, you have a job which that thread was supposed to do, and that job execution has failed in between. Yeah, method execution failed because exception has occurred and it has come out. What would you like to do? What should be done? Yeah. See, this is my thread of execution. There is a corresponding thread object somewhere in the heap, okay, which corresponds to this. Because you called the start here, this was created, right? We know there is a one-to-one correspondence. For every runtime stack, there is a thread object. Okay, fine. So now, what we have here is, if a thread terminates because of an exception which has not been handled, fine, what should be done? What is normally done? What is normally done? Have you seen some output? it prints a stack trace. What we find is a print of a stack trace. Fine. If something terminates, we see a stack trace. If it is because of exception, then a stack trace is, we never said I want to print a stack trace, but it does a printing of stack trace. Let's see how all that happens. And it's not only about that. What we have here is we can decide what should be done when a thread terminates because of an exception. Okay, what we have here is one interface. So there is an interface used here. The name of the interface is, it's an interface inside the thread class. Okay, so within the thread class, we have an interface declared inside this. The name of the interface is uncaught exception handler. There is an interface called uncaught exception handler inside the thread class. So thread.uncaught exception handler, and that's the interface. This interface has only one method. Okay, this interface has only one method where return type is void. Name of the method is uncaught exception and has got two parameters. The first parameter is the thread which has terminated, the thread object corresponding to the stack which has terminated, and the second parameter to that method is the throwable object. The throwable which caused the termination. So we have this interface called uncaught exception handler. Okay, so let's look at what is this uncaught exception handler, how it is used. Okay, so now what we have option here is, we have an option of now the pair of method in the thread class first. So in the thread class, we got a method returns void. Name of the method is set uncaught exception handler. And what's the parameter? That thread dot uncaught exception handler. Fine, it's a uncaught exception handler. Okay, that's your handler. The uncaught exception handler. So on an object of thread, you can say, okay, that's your uncaught exception handler. Fine. We even have the other method which would return thread dot uncaught exception handler. Okay, fine. Name of the method is get uncaught exception. So there's a get and set method. And think of this as, because it's an interface with single abstract method, fine. You can think of lambda here, it's a function. And that one is a function with two parameters. A function with two parameters. Fine. Where return type is void. So it's a by consumer, right? More like a by consumer, similar to a by consumer. Okay. Okay, so what you are allowed to do is, you have your thread object here, let's say, right? This is the thread object, and on this thread object, you can create one object of function, right? This is nothing but a function object, which is your uncaught exception handler. Fine, which can then be set here on the thread object. It can be set as a the handler for the thread object. Now, if this has been done, okay, that means you can write your own implementation of the uncaught exception method, where a thread and a throwable is available, and do what you want to do. Fine, clear? So now what you are supposed to do here, you are supposed to write a code where, given that this particular thread has terminated and this was the throwable which caused the termination, write the code. What would you like to do? Fine, that's up to you. Okay, fine, you can write your code, and if that method, that object, a function object is created, you can set it on a thread object. This is how I handle if a thread, if this terminates because of an exception. This is the handling, this is the method which should be used. So whenever a thread would terminate, if this thread terminates, if it is terminating normally, nothing. If it is terminating with exception, it will go to the thread object, check if there was a setting like this, if there was a handler set on it. If you have set the handler, then invoke that method and then it finishes. So before the thread finishes, yes, it would result in invocation of the method. This method which has been set, it's like setting a method, right? This method has been set on a thread object. You can set it on a thread object. Okay, if you don't set, then what will it do? Oh, we have another possibility. Fine, maybe you don't want to set it on an individual thread. Fine, but you would like to have one general rule for any thread which, if there is any thread terminating in my JVM, if any thread terminates because of exception, I would like to do this. You define your function, implementation of uncaught exception handler, and we have static method in the thread class. And static method returns void, name of the method, set default. Default uncaught exception handler. Set default uncaught exception handler. Parameter, you can understand what's a parameter. Thread dot uncaught exception handler. Fine, that's a handler which you want to have. Set as well as, what's the other method? Other way around, the method would return thread dot uncaught exception handler. Okay, name of the method is get default uncaught exception handler. No parameters. So a method to return the default setting. Fine, this is a static method. So across. Fine, single object, not on a per thread basis. So you might have set a default uncaught exception handler also. Okay, so what should be done? So now this is about what should be done when a thread terminates. What exactly is happening? Fine. Again, see one more point. This set default uncaught exception handler, again, you may or may not have called it. If you have not called it, there's no such setting. There's no default setting. Yeah, you have option of uncaught exception handler object being to be created, and then using the static method to set it globally, or setting it on an individual thread object. Okay, two things. Clear? Or you may not have set anywhere. Let's see exactly what would happen when a thread would terminate now. If a thread terminates because of an exception, the first thing it would do is look whether there is a, on this thread object itself, there is a exception handler which has been set. That means the object of thread, fine, someone has used the set uncaught exception handler and set the object. If it has not been set, it would be null there. Okay, in such a case, it would look for the default. If the default setting was done, okay, that's a place where I know the method to be executed is the uncaught exception method. Fine, it will execute that method, but even that has not been set. If that has also not been set, then it looks at the thread group of the thread. Oh, this thread belongs to so and so thread group. Fine. And thread group implements the uncaught exception handler. This method is implemented in thread group also. So it will then execute on the thread group. Okay, fine. Last time I was mentioning thread group is similar to a, it's like a community. Okay, now let me relate this so that you can remember this easily with the real world example. Fine. What is our thread? Thread of execution? It's like a person. Now, when a person dies because of an exception, oh, accidentally, he didn't complete his job. Fine. What should be done? The last thing to be done is you have to look at the will of the person. If the person has a will, that has to be seen first. So on the thread object, see on that individual thread object, right? That's the person. Oh, he has something. He has to say something. Oh, that has to be, that's the thing to be executed first. If there is no such will, no such thing as, he has not set a will, then you go by the law of the land. Fine, go by the law of the land. Fine. If there is some rules, fine, of the government, right? You have some uniform civil code or something, right? In that case, go by that. But if you don't have any such law also in place, then what's the thing to be done? The last thing to be done has to be according to the community to which he belongs. Fine, go by the community. Go by the thread group. So the thread group is decided. Thread group is implementing. So in thread group, there's this method already there. Thread group implements uncaught exception handler. Simple. It can be remembered now how it happens. Clear? So there's a mechanism. Fine. This is similar to what happens in real world. Okay. Fine. So uncaught exception handler. This thing is fine. Now we might like to look at the class called thread group. Let's try to look at thread group now. Okay. Let's take another page. We look at the thread group. Okay. The thread group class. Okay, just one more point before I go for thread group. Let me change that topic. Instead of thread group, there's one more point to be taken. Okay, let it remain. We can go to board 1. And let me just finish just one more point here. One of the properties of thread which I have to still discuss, I would like to just put it here. We have this property called, okay, we have one more getter method. It's a get only method. Fine, get method. In the thread class, there is a enum. Thread.State. There's an enum called state in the thread class. It's an enum inside the thread class. And we have the method called, in the thread, we have the method called get state. What is the state of the thread? Fine. Let's look at the states of a thread object. Fine. State is a enum. Fine. The state is a enum. Okay. The various values in the enum state. Let's check that. Fine. Let's see what are the various. It's a enum, so a fixed number of objects, right? So let's see what are the state of a thread. Fine. As available from the enum here. So in the thread.state, there are enum values. It starts with what would be the initial state of a thread? When you create the object, the state is said to be new. So that's one of the constants in the state. So thread.state.new. New is 1. Initially it is in the new state. Fine. After the new state, after it has been created, what's the thing that would happen? You'll be calling the start method. When we call the start method on a thread object, the thread goes into a state called the runnable state. Fine. Thread is in the runnable state, where it is now executing the method, the task. It has now started executing the task. Okay. Fine. While it is executing the task, there will be various instructions. There will be instructions for doing some kind of an IO. Fine. There will be other kinds of instructions where you might have introduced some kind of a delay. Fine. You want the thread to have some delay before it goes to the next instruction. Fine. Intermediate, you might like to introduce delay. There's a method like sleep, and so there are various methods where the thread is going to go into a waiting state. Okay. Fine. The state of a thread can be, yes, it runnable means yes, it can now run. Fine. It's waiting for the CPU to run, or it is actually running. Runnable includes both the things. Okay. Or the other thing what could be happening is waiting for something. Fine. It's waiting for something. So we have a state called waiting state. And another state is the waiting state. But there are two kinds of waiting state. It's waiting for some resource. It's waiting for something to happen. Or it could be waiting for a fixed amount of time. It is waiting at the most particular amount of time, waiting with a timeout. So if there is a wait with a timeout, it's known as, the state is the timed waiting. Fine, we have the new, initially new before we call the start method. Calling start puts it into the runnable state. Fine. While executing, it may go into a waiting state. It might go into a timed waiting state. There's yet another state where it can go into. Fine. It's again kind of a waiting, but it's different from waiting and the timed waiting. It's known as the blocked state. Fine. The state could also be a blocked state. This thread is blocked. It's waiting, actually, it's blocked means yes, it's waiting for a resource. Not the IO resource or something. It's a waiting for a resource which is currently used by another thread. A resource which is currently used by another thread. That resource is nothing but lock on another object. We'll talk about locks later, locks on objects. Fine. In Java, we have locks available on all objects. So a thread could be saying, oh, I need the lock of that object. And this is done basically for synchronization purpose. And we'll come to that problem, why we need synchronization. Fine, at that time we'll be able to understand this. But there is also a state called the blocked state. Fine. So yes, from new it will go into runnable. When it starts execution, it may go into either of these states and come back to the runnable state. When it is in runnable, it may be able to execute and proceed further. And ultimately, it will finish its task, successful or unsuccessful, or whatever way, but it ultimately finishes the task. When it finishes the task, the thread is said to be in the terminated state. And so that way, we have this method called get state on a thread object to know the state of the thread. And any thread, fine, what is the corresponding runtime stack? What is the state of the thread of execution? That can be known. So these are the 6 different state of a thread object, yeah. Fine. Okay, fine. Now let's proceed with the thread group. And clear up to this? Fine. Let's now have a look at the thread group class. Okay, thread group. Yeah, what is a thread group? It's used for managing threads in a hierarchical manner. Fine. Fine. We can manage our thread objects in a hierarchical structure by using thread group. Okay. So let's look at the constructors for thread group. A thread group could be created by specifying. Thread groups have actually 2 attributes. So you may specify the 2 attributes. A thread group can be created by specifying another thread group, which is nothing but the parent. You want to create a new thread group as a child of another existing thread group, and you want to specify a, so every thread group always has a name. Okay, or you might be able to create a thread group where you only specify a string for the name of the thread group. You are not specifying the parent. When you're only giving, so 2 constructors available for thread group. And you might be giving thread group, which is the parent thread group, and the name. Okay, so 2 attributes we can see initialized using the constructor. Now, when you don't specify the thread group, when you don't specify the parent of a thread group, fine, what will be its parent? What will be the parent of the new thread group which is being created? Yeah. Okay, let me put the methods, the 2 methods which are get methods. We don't have set methods here for the 2 attributes. So we only have the get method. So we have a method to return the thread group, which is a parent. So we have a method called get parent, and another method to return string get name. You can't change the name of a thread group once created. You can't change the parent of a thread group once it has been created. And when we use the second constructor, where we are not specifying the parent, what would be the parent of such a thread group? No, it's not going to be null. It's not going to be one more independent thread group and having its own childs. No, not going to be the root thread group. Okay, the parent of this new thread group, or who called the constructor of this thread group? A thread group object would be created only when someone calls a constructor. Who does anything? Some thread. So whichever thread called the constructor of the thread group, that thread already belongs to a thread group. That thread belongs to a thread group, and that thread group becomes the parent of the new thread group. So the creator's thread group, fine. What's a parent if not specified? It is the creator's thread group. Okay, that is the parent thread group. Fine. See, now just to give a start here, a little understanding about the picture, some kind of a pictorial thing related to the threads and the thread group, the way they are arranged. Fine. Now this can be different in different versions, that can be revised also. But what we have found, okay, from Java 1.4, or yeah, it was from 1.4 onwards. Earlier it used to be a slightly different arrangement. Okay, what we have found is there is one thread group at the top, okay, whose name is system, and I'm putting the name of the thread group which is getting created as the root. Fine. And then we have a child thread group under this whose name is main. Fine. The main thread which is created under this. So there is this main thread. That's a thread object which is whose name is main. When we have the start method done on this, so there is a corresponding thread of execution for the, that's where the main is executing. These two are there. Fine. There is a correspondence between a main thread object which is belonging to the main thread group, whose parent is system. And then I was talking about the other, it's not only the main thread, there are other threads as well, the garbage collection related. There are 3 or 4 other threads which are created here. They are directly working under this. I'm showing this arrow on the side to indicate the execution sequence. They are live, okay? They have life here. Fine. So that way 3, 4 things are here. When this is what the initial picture is. Fine. These things which are executing here, here, and here are the things which are related to managing the JVM. The memory management has to be done. So the garbage collection thing. Okay. But this one here, and this is the main, that's your code. That's where your code starts execution. Execution of your code is happening. Fine. From here, you are writing, from here is your invocation, from your main here, you are writing code to create other thread objects. When you create a new thread object, fine, you can specify a thread group in the constructor. You can create new thread group objects. When you create a new thread group, you must specify a parent. Fine, one of those two. Fine. You can create them wherever you like in the hierarchy here. Fine. Yeah. So you might create a new thread group and you don't specify the parent automatically. Who is doing it? The main is doing it. It's creating a new thread group object maybe. So you call the constructor of thread group. It created a new without specifying the parent. Then what would be the parent? Because it's done from main. Main is this main thread, has the main thread group here, and therefore the parent of this would be here. Fine. When you create a new thread object from here, you might use this in the constructor and create one thread object here. Fine. When you create a thread object, there are constructors which can take thread group as a parameter. Fine. If you don't specify the thread group, the creator object's thread group will be used. Fine. Clear? Fine. Parent. So how the parent-child relation will be created? between thread groups. And then when you create any thread object, you can choose to use any of the thread group. Yeah? Like you want to create a new file, you can choose to put it in any of the folders. And same way, you can choose any of the thread group which is available to you. Fine, and create a, so fine, so tree-like structure, thread group and thread objects. And the execution is separate. These are objects, arrangement of objects. Execution is that runtime stack I've shown with arrows. Objects are separate, execution sequence is separate. And always remember that distinction between the execution sequence and the object. Okay. Objects simply have information, the priority and other things, what type of thread it is. And these threads which are here in the system initially, right, these are all daemon threads. Fine. See, we can get that information even by using get all stack traces. And you can get all the thread objects. And we have seen that. And I had shown one line of code which was saying how to get all the thread objects which are alive, for which there is a runtime stack. And so one small experiment we could have, one small exercise can be done easily, where we can see all the thread objects, get all stack traces, and then print information about all the various properties. We know the methods to print the properties. Okay, so that's one thing which we can do. Okay, now coming to what is there in a thread group object. One part of thread group is to arrange them in a hierarchy. Another purpose of the thread group, we do have methods. If we call on the thread group, fine, the methods are, there are certain methods which are common to thread as well as thread group. So there are methods which are available on thread, and same method has been made available in thread group, so that if you call on the thread group, it's like invoking on all the threads under the thread group. Fine, for example, fine, I'll show some example of such methods. So this method, what I'm going to now write, are methods available in thread as well as thread group, both, common to both. Okay, so in thread also we have this method which returns void. Name of the method is interrupt. Fine. Another method which returns void. Okay, name of the method is suspend. Another method returns void resume. And another method to return void, name of the method is stop. Fine. The first method is interrupt. The other three methods here, fine, suspend, resume, and stop. Okay. Those methods are deprecated methods. And we should try to understand why they are deprecated. When we have the method called interrupt, that's not deprecated. But the point here is, if I call it on a thread group, it would in turn be, it's just like invoking it on all the thread objects belonging to that thread group. It's a group level method. Fine, I think we'll have to continue next time. Fine, so next time we'll continue with this thread group, discussion on thread group, and then we'll look at more methods on the thread class.